In this video, we're going to be solving a word problem using a system of linear inequalities. Okay, so Deshaun will donate up to $460 to charity. Up to means less than or equal to. The money will be divided between two charities, the City Youth Fund and the Educational Growth Foundation. Deshaun would like the amount donated to the Educational Growth Foundation to be at least twice the amount donated to the City Youth Fund. At least means greater than or equal to. Let X denote the amount of money in dollars that goes to the City Youth Fund, and let Y denote the amount of money in dollars donated to the Educational Growth Foundation. Okay, shade the region corresponding to all the values of X and Y that satisfy these requirements. Okay, so we know that X is the City Youth Fund and Y is the Educational Growth. And we know that Deshaun will donate up to, that's less than or equal, $460. So we know that X plus Y is less than or equal to 460. Okay, so that's our first inequality. Our second one comes from this. Deshaun would like the amount donated to the Educational Growth Foundation, which is Y, to be at least twice, or at least means greater than or equal to, at least twice the amount donated to the City Youth Fund. So educational was Y, okay, and at least twice would be greater than or equal to, and it's twice, so I'm going to put a 2 on the X. Okay, so we have two inequalities now. We know that the Educational Growth Foundation gets twice as much money as the City Youth Fund, and we know that the total has to be less than or equal to $460. A couple other things that we know about this problem is that we're not going to be in the negative on any of this. That would mean that the charity was actually giving money to Deshaun instead of the other way around. So we know that X is going to be positive, so I'll say greater than or equal to 0, and Y also has to be greater than or equal to 0. They can be equal to 0, but not below 0. That would be negative money. All right, so let's go ahead and graph these. First, the X greater than or equal to 0. This is the X-axis down here. If it's greater than or equal to that, then there is a line right here on the X-axis. So let me draw that real quick. Okay, there's that line for greater than or equal to 0 for the X. Now I'm going to do the one for Y. Okay, so there's the one for Y. So I have to stay in this region here. Now I can graph these two lines. Okay, so to graph Y is equal to 2X, first let's think of it as an equation. Y is equal to mx plus b. 2x, 2 would be the slope. And since there's no number here, there's no y-intercept other than 0. So it would start at 0. So there'd be a point at 0, 0 right there. And if I wanted to get another value, I could just plug in any x value I want. So let's plug in, say, 120. So if I plugged in 120, I get y is, and I'm just going to say equal to, for the purposes of graphing, equal to, and I'm plugging in 120. So 2 times 120 would be 240. So that gives me the point 120, 240. Okay, and I could have plugged in any of these x values. I just chose 120 because it was right there on the graph. Let me graph that real quick. There's the point, 120, 240, and there's the graph. All right, now finally let's do the x plus y, and I'm going to say x plus y is equal to 460 just for the purposes of graphing. So let's move the x over. It will give me y is equal to 460 minus x. Okay, so my slope is -1 and my y-intercept is 0. Another way that you could do this might be a little easier is to just find the intercepts. So let's say if x is 0, what is y? And if y is 0, what is x? Okay, so pretty easy to see. If I plug in x equals 0, this x goes away and you're left with just 460. Okay, and likewise, if I go back up here and I put 0 in for y, well, x is equal to 460. Okay, so those are the two intercepts, which makes this thing easier to graph. So let's plot those points. There they are. And now I'm going to connect the line. Okay, there's the line, and I've labeled the graphs. This is the y is greater than 2x, and this is the x plus y is less than 460. Okay, so the shading we can use, we can just use the greater than or less than. This is saying y is greater than that. Y is greater than 2x. So I will shade above that line, right, because it's greater than. And this one is saying x plus y, or if you go over here, y is less than or equal to 460 minus x. So it's saying less than or equal to. So I'm going to graph below this line and above this line, below the x plus y line and above the 2x. And remember, I can't go left over here because that's negative, and I can't go down here. So the part I'm going to shade is this right here. And that's my answer. Let's do another one. Okay, Teresa does a weekly exercise program consisting of cardiovascular work and weight training. Each week she exercises for at least 7 hours. Okay, at least means greater than or equal to. She spends at most, less than or equal to, 4 hours doing cardio, and she spends at most, less than or equal to, 12 hours on weight training. Okay, X will denote the cardio, and Y will denote the weight training. Okay, so let's see. I'm going to still have the same stipulations I had on the last problem, in that she can't spend negative time exercising, right? So I can't go over here and I can't go down here. All this region is off limits because that would be negative workout time, which is not possible. So I'm going to put a line right here and right here on X is greater than or equal to 0 and Y is greater than or equal to 0. So let me do that real quick. Okay, there's those two. So I have to stay up here in the first quadrant. Now, what else do I have in this problem? Let's go back up here and look. So each week she exercises at least 7 hours. So that's all the cardio and all the weight is at least 7 hours. So that's going to be X hours in cardio plus Y hours in weightlifting is at least, so less than or greater than or equal to 7. Okay, and then one more, we've got, or actually two more. She spends at most 4 hours doing cardio. Cardio was X, and at most 4 hours means X is less than or equal to 4. And she spends at most 12 hours on weight training, so that's Y is less than or equal to 12. Weight training is less than or equal to 12. So I need to graph all these lines. Now graphing the X is less than or equal to 4 and the Y is less than or equal to 12 is pretty easy. I'm going to go ahead and do that. Okay, here's those graphs. So this is the Y. On the Y-axis, I went to 12 and did a horizontal line. So it's less than this line, so I would be shading under. And then at 4 on the X-axis, I made a vertical line, and it's less than this number, so it would be to the left. Okay, I've got one more line to do. I've got this X plus Y is equal to 7. Okay, and I'm saying equal to just so I can graph it. I'll talk about the shading and the inequality in a second. So again, I'm going to just plug in a 0 for X and get an answer for Y. And then I'm going to plug in a 0 for Y and get an answer for X. Okay, so if I plug in a 0 for X, that goes away and you're left with just Y equals 7. And if you plug in a 0 for Y, the Y goes away and you get X equals 7. Okay, so I can plot those points and graph a line. Go ahead and do that. Okay, here we go. Plotted the point 0, 7, and 7, 0. Here's the inequality. Okay, so now let's shade, and we'll be done with this problem. So this says X plus Y is greater than 7, so I would be shading above. This says X is less than 4, less than or equal to, so I'd be going left. So above this line, left of this line, and this says less than 12, so I'd be below. And remember, I can't go over here because it's negative, and I can't go down here because it's negative. So the region that I am shading is right here. Okay. Let's do one more. A garden will use up to 230 square feet, so up to means less than or equal to, for planting flowers and vegetables. He wants the area used for vegetables to be at least 4 times. At least is greater than or equal to, at least 4 times the area used for flowers. Okay, so X is used for flowers, so let me write that down. And Y is going to be used for vegetables. Okay, So shade all the corresponding values. Okay, so just like the last two, remember that we can't have negative area. This is a garden. It can't be negative space, all right? So x has to be greater or equal to 0, as does y. Both of them have to be greater than or equal to 0, so we have to be in this first quadrant. So let me go ahead and graph those. Okay, there's those graphs, so we will have to be here in that first quadrant. Now let's look at the other equation. So up to 230 feet for both flowers and vegetables. So x and y together gives us up to 230 feet. So x plus y less than or equal to 230. Okay, and then our other equation comes from this. He wants the area used for vegetables to be at least 4 times. So remember, vegetables is y. So vegetables, or y, is greater than or equal to, that's at least 4 times x. Okay, so once we graph those, we will have the problem. Okay, so let's do the x plus y is equal to 230 for graphing purposes. I'm dropping the inequality for a second. And I'll do the same thing that I did on the other problems. I'll plug in a 0 for x, and I'll plug in a 0 for y. If you plug in a 0 for x, the 0 goes away, and you get y is equal to 230. And the same thing happens for x. If you plug in 0 for y, then x is equal to 230. Okay, so let me graph those real quick. Okay, there's the line right here. Here's the intercepts that I plotted. It was between 220 and 240. And this is x plus y is less than 230, so I'd be graphing below that line. All right, now let's take a look at the y is equal to 4x. Okay, so I can plug in a point for, well, I could plug in 0. If I plugged in a 0 for x, if I plug in a 0 right here, 4 times 0 is still 0, so I get 0, 0. So that's at the origin here. And then if I was to just pick some other point, let's just pick any point, any of these nice points down here. I'll choose 100. Okay, so I'm going to plug in a 100 in for x. So 100 in for x, what do I get in terms of y? Well, I would get y is equal to 4 times 100, which is 400. Okay, so 100 comma 400, and that's 100, and then 400 is off the map, so used a number that was too big. It's not that big. So let's use something smaller. Let's say 40. So this didn't work very well, but that's all right. So if I plugged in a 40, that would give me y is equal to 4 times 40, which is 160. Okay, that's more reasonable. So 40 comma 160, I can graph that. 40 and then 160 is here. Okay, so I've got my origin point and this point. Let me connect those dots real quick. Okay, there's the line. I have the 2 lines here, and remember we have to stay in the first quadrant because y is greater than 0 and so is x, so it's got to be in here. This line is x plus y is less than 230, so I'd be shading below this line. But this is y is greater than 4x, so I'd actually be shading above this line up here in this region. So below this line and above this line, there's my shaded region. And that's it.